Hello and welcome to yet another video. Today we have an MSI Pro 760M-P DDR4 version of an Intel mainboard. Let's get this unboxed. As you can see, there's barely anything in here. There's the I/O shield and the actual motherboard itself. So first thing I can see is that this socket has a little bit of damage here on the right. We need to look at that under a microscope. But other than that, this looks fairly clean. This came to me for no boot, no reaction to the power button. So let's first go under the microscope and see for these CPU pins. Okay, we're now under the socket, or looking at the socket. And as you can see, we have this pin right here. And we have this pin right here. But they look very fine, to be honest. If you look at the rows from the top and from the sides, these tips are very well aligned with the others. Here a little bit less, but still very nicely aligned. It looks like they got thermal paste or something on them, like something sticky. They might just need cleaning, just like this one here. Yeah, it really looks like it's thermal paste on here. So this shouldn't be a problem for us. It's just very dirty. There's also hair just all over the place, if you could see. Just with a quick blow, most of it removed. So the socket isn't a problem here, actually. So that's a good thing. Don't want to replace a socket, I want to repair one. So let's get into measurements. So let's then get on with our usual measurements. Let's take our probes, connect to ground, and go into 12 volts, kilo ohms and rising, 5 ohms, 5 volts, kilo ohms and rising, 3.3 volts, kilo ohms and rising, 5 VSB, 770 ohms. Okay, we're going to keep that in mind. PS on, 10 kilo ohms. That looks very nice. Let's go into the 12 volt socket for the CPU. Kilo ohms and rising. Let's go around some voltages. Let's just check the battery quickly. Let's go into the battery. The battery has 3 volts. Let's go into resistance mode again. Let's check around the SIO. We're going to use random capacitors around the SIO. This has 100 ohms. And this looks weird. Let's see for this. Let's go under the microscope. I'm going to show you what capacitor I'm probing. So we can now see the SIO. And what I always do is I go onto a random capacitor like this one. And let's see for its resistance. And as we can see, we have 9 ohms. That is very low for an SIO. Let's see if I can find the voltage regulator for this. Something like this looks like it's voltage regulator. The voltage regulator for SIO most of the time is this 5-pin. And then one of these two is most of the time the output for it. Let's see if we can get any resistance on here. And this is the resistance, yeah. So this has around 9 ohms. This is very low. This is probably either 1.8 but probably a 3.3 volt rail. And what we can do is we will supply voltage onto here, and we're going to see under a thermal camera just to confirm if this SIO is dead or not. So right now I have 1 volt attached to the probe, or to the tweezers right here, and we have our thermal camera roughly in the area around the SIO. And let's now see, we're starting with 1 volt onto here. And we have a little bit of power draw. We have 10 milliamps, and you can see it's getting a little bit warm. This is just my hand. You can see around the SIO a little bit. Let's go for the 3 volts that we need. Oh, let's start with a little bit over 2 volts. Oh yeah. Now you can see way better that this is normal. And let's now, just to confirm it, go for the 3.3 volts that this thing actually requires. And this rises very quickly now. So on this rail, we have 330 milliamps of power draw with 3.3 volts, and the SIO getting quite hot. Like, the resistance is not quite what I expect from a completely dead SIO, but it's definitely dead, because 9 ohms is too little for this one. And yeah. So what we need is an NCT6687D for this mainboard to be repaired. And what I have here is an NCT6687D-M, and as you can see, this is the chip that is on here. So you might have guessed that I have already diagnosed this board before and just wanted to show you the process again. And what I want to show you today in detail is how I solder an SIO, because it isn't that easy and I still struggle sometimes with soldering on a new SIO, but we're going to go through that journey today together. So first things that we need to do for soldering an SIO is preparation, and there's a lot of stuff that you can do and might need to do. And one of the first things I do is I want to remove as many heat sinks as I can around the SIO. So what I would do is to remove this M.2 cover, and another thing that I would do, I would remove this PCH heatsink. Another thing that you can do is remove also from the socket like the socket itself, basically, by removing the screws. This is not too hard. And what I would also do is remove the heatsinks for the VRM. In this case, this mainboard doesn't have heatsinks for the VRM, but let's take the PCH heatsink off as well, which this one needs pliers in order where you need to push them in, push them together, and then you can remove them. Just like that. And let's see, let's get this off. Let's put this to the side. And now our board is mostly prepared. Another thing that you can do is use Kapton tape to tape off this connector and these connectors, and maybe this capacitor down here. But I think we should be fine going with heat into this area without melting any of these connectors or blowing up these capacitors. So what I like to do is I have a preheater that I use for stuff like this. So it would be easier to remove this one because I use hot air to remove SIOs. So let me get that prepared. So now our board is on a preheater, and I'm going to be turning this preheater on, and I will be starting with 250 degrees of preheat. So what this will now do is to get the board up to a good temperature where we can easily solder on the board. If you set 250 degrees on the preheater, at least on mine, the board won't reach 250 degrees. It will be lower than that. I have never measured where it will actually end up on, but it definitely won't end up on 250 degrees, because this preheater goes up to like 400 degrees, I think, at least the display says, and it will definitely not reach 400 degrees. So let's now go under the microscope, and we're now under the microscope and we see the SIO. And what I like to start with is put flux on there. As you can see, there's flux on there, and then use my soldering iron to then apply leaded solder onto most of these or nearly every single leg. So what I do is I get a good amount of solder onto my soldering iron, and then I just go around the SiO trying to spread the leaded solder to lower the melting point of the legs, because what we will do when this is heated up, we will be using hot air to lift off this SiO. So just spread it around. And you really don't need a preheater for this, because for now this the preheater didn't really start even, and we are already already very easy to apply the solder onto here. Let's do the last side as well. So we now applied leaded solder to everything. What I like to do now is I want to wait a little bit for the preheater to do some work, preheat this board, and then we will take our hot air station and we will be trying to take off this SiO with hot air, with tweezers, and then do the preparation to put on the new SiO. One important thing to remember is if you can take a picture of the layout, especially to see where there are passive components around the SiO and what orientation the SiO has. Because it can happen to you that you try to take off this SiO and you knock off some of the passive components around here. And when you don't have schematic, it could be really problematic to replace these. So keep that in mind, and also keep the orientation in mind. So we have the dot right here, and I think pin 1 should also, yeah, it's in this corner, is pin 1 as marked on the board. So I will be waiting for the preheater, and then we'll get you back into here as soon as I will be using hot air to get this thing off of here. So our mainboard now is nice and hot. We've got very good preheat on here. And what I like to do is also get gloves onto here, because the mainboard is very hot and the area around it is very hot. So I have some heat resistance gloves just to make my life a little bit easier, because everything around the preheater is also very hot. And I did have burned myself before, so we're not going to repeat that today. But what we're going to do, I have good tweezers. I will be lifting it up from the bottom right here. And what we're going to do is going to start the hot air station now. I'm going to go with 400 degrees and 85% airflow. And what we're going to do first is we're going to be preheating it from the top. So we're just going to get heat in from the top in the general area now. And we're gonna go nice and slow. Just going around the area and seeing for the solder, because most of the time you can see when the solder actually melts and becomes molten. So a big key part here is patience, because what can happen, what I have done before, is when you can lift up one side of the SiO, but the other one is still soldered on, where it happens that you lift one side but rip pads of the other side. And it's off. And what you could see there very well, I started to lift from the bottom right corner, and the top left corner was still holding on. And that was very important to just lift this corner, and then when this is lifted, go with the hot air closer to that top corner, and then only try to lift off the chip, because you will rip traces if you don't do that, because that side is still soldered on while the other isn't anymore. And yeah, you will be very sorry, because I had to repair a lot of traces before, and that was just awful to work on. So what I like to do now is I like to solder, to wick off all of the existing solder off of these pads while everything is still nice and hot. Get them all cleaned up. So most of the solder stayed on the SIO. Most of it is here. And what we now will do is we now will apply leaded solder again onto these pads. So what I like to do first is clean off the old flux that is on here. Just using some cotton buds and maybe some wipes. Just getting this area clean. It's mostly very easy because it's still hot. As you can see, the cotton bud gets very dirty because this is burnt flux. So now our area is very clean. We have no solder onto there, no flux. What we're going to do now, we're going to use some fresh flux. Going to be fluxing up this spot. Going to be on here nicely that we have enough flux. And what we do, we use our leaded solder yet again. And now we're going to be applying leaded solder to all of these pads, that they're going to be having a nice fluffy pillow on all of these. So with a good amount of flux, you can put a lot of solder onto these. And we want to get them not touching each other, like here. And like there. We want leaded solder on all of these, but not to have too much on there that stuff keeps bridging. And on this side right here, where it doesn't look as great still, apply some new flux. And now we should be fine on all of these. All have leaded solder. We're going to be taking off that solder blob that we've created. Let's see, this shouldn't be soldered on. Okay, it is soldered on. Can't remove it like that. Okay, let's try to get it off like this. Yes. So always cleaning your tip in between. Getting this off. And now the next thing, what I like to do, this might be a little bit controversial, but I like to now get my SIO. And let's see what way we need to put this one down. We will need it like that. So let me get it out of its protective film. So let's flip this onto this side. And what we need is to go this way. So now what I like to do is to get it mostly lined up. As closely as possible, I want to get it lined up. And you always need to look in all of these corners. And it is a little bit hard to get it lined up because we did put solder onto each pad, which makes them have a pillow on them, which makes it harder to line up the SIO. But we don't need it to be perfect right now. What we want to do is we just want to tack on a single side. And now I've moved it again. So taking tweezers here, pushing against. And I just want to get it a little bit to hold onto here. That some pins will hold it. Because the rest of what we are going to do is we're going to hot air this on, that it will lay down into the solder that we have. The soldering on of these legs just was to prevent it from flying away from the airspeed. So we again use 400 degrees, and with 85% airflow, we're now going to be melting the solder around the SIO. Now we can already see some of these pads melting. Now the big thing is going to be, we will be needing to push it into its place. Let's see. Now one big problem is again to get all of the pads at the same time to be molten, and it's sadly shifted. Okay. Now we need to move a little bit down, yeah. This right side is not quite where I want it. Because what you can see, this top right corner still needs to go a little bit down. And now we went a little bit too far even. We want to move back a little bit here. And now we are lined up, and what I like to do is like to push down on the SIO and not move it out of place again, to make sure that all of the pins actually go down far enough and make contact. Now I moved it too much. Oh. Okay, I think we got it. I think it moved just into place. That was a lot of heat, a lot of back and forth. But I'm pretty sure that we got it. As you can see, we have all the legs lined up with where they need to go. And what we now need to do, what sadly happened this time, this happened to me quite some times before, but some of these legs are not soldered properly. Some did attach, but some didn't. And now comes the gruesome task of trying to find these pins and to solder them on. Like, I can show you right here. These pins here are not properly soldered. And I will be going around the SIO now, and I will do this off camera, but all I did is I still have the preheater on, I have a small tip, and I will be going onto each pin and see that it's soldered on. There are methods of drag soldering, but I sadly don't have the right tip to do that. Drag soldering right here would be the good thing to do and the easier thing to do. But I will be using the small tip, going to be going over them individually, and will be soldering them on. And when I've done that, I will get back to you, because this is just going to take some time. There is nothing really interesting in here. Like, at some point you will bridge them like that, and I will be just taking that out with the soldering iron. So yeah, nothing too interesting to see, and I will get you back into here as soon as I went around the SIO once and got solder onto these legs. So I now want to show you the result. As you can see, the SIO is soldered into place. It's not the prettiest, most definitely not. Like you can see at the bottom right here, it happened to me that I moved the pin, but it's still soldered. And I got to be honest, it took me way longer than I thought it would. And yeah, but it is on now. I don't really know. I got to be honest. I wish the method would work where I just hot air it on, like I tried to. Don't really know what the problem is in my case, why it won't set down, because I even later tried to reflow it, pushing it down from the top, but that also didn't work. Yeah, and I don't really know what I should be doing differently. Next time, what I might want to try is to pre-tin the legs of an SIO. So if I have in the next time trying to put an SIO on, I will just pre-tin all of the legs, and then I will try to solder them to hot air it onto the board. But what we want to do now, the board has already cooled off and I've cleaned most of the flux, not all of it, but most of it is cleaned. Let's get onto this thing here again, and let's see for the resistance that we have. Before, to remind you, we had 9 ohms, I think it was. And yeah, let's see where we end up now. What should be the normal voltage, normal resistance for this SIO? And we have 3.3 kilo ohms. That's a big difference than we had before with the 9 ohms. 3.3 seems kinda high kilo ohms, to be honest, but who knows? We will be trying this out now, going to build this board up, and we're going to see. And now we are built up. We do have a CPU in here, we have DDR4 in here, we have the postcard in here. We're using the internal graphics. What we also have is post LEDs. So the top one is CPU, then we have DRAM, then VGA, and then boot. So it goes from top down. I will plug a keyboard into here to have an indication. And let's now see for the passive power consumption. That looks very good, around 100 milliamps. So the SIO is not burning up. And let's now press the power button. And we have reaction to the power button. We go to DRAM LED. Let's see. We have good power consumption, 2.5 amps. And it seems like we're kinda stuck on DRAM LED right now. The current is jumping pretty high. Let's see if it's going to do something by itself, or we might need to reseat the RAM. Okay, I've reseated the RAM. Let's see if we're going to move further. We have 3.3 amps. Now we move further. Okay, just needed a little bit of reseating. And it turned off by itself. Are you going? Yes, it starts by itself again. This is good behavior. And let's see if we can now get a picture out of this. We now have the third LED. And we have boot. And I do have an indication on the keyboard. And let's say show you this. So you can see the keyboard is reacting. We don't have a picture currently. Let me quickly turn this off and I will see why we don't have picture. So I can't get a video output out of the BIOS, but let's see. I've installed an M.2. Let's see if I can get a video output or video capture out of when we go into Windows. And there we have video output. So I cannot capture the BIOS of these newer boards, but what we can definitely do is capture Windows. So I'm going to populate this board with more RAM, and then we're going to see if everything works. I'm going to put a GPU onto here, but this already looks very good. Our SIO has read the power button. This is one of the most important things that I would say, that the board needs to be start up with the SIO and has to read the power button. And I will get you back as soon as I have tested it and have put more things into here. And now, as you can see, we have Linpack passed without any problems. I will get into 3D benchmark next. So Unigine Heaven has also passed without any problems. And that's basically it for this repair. This board now works. I've tested USB, Ethernet is working. The 3G application has passed with the graphics card. Linpack has passed, M.2 is working, and I'm happy with this. I can't see any more damage on this one. I want to tell you that I've been asked by multiple people if this is like economical to do, and I gotta say this board is not worth very much. I think it's like new $60 or something like that for a B760M board, and it, for all the time you spent in here and me needing to buy this board, it just isn't worth actually doing the repair if you're just in for the money. But I'm here for the experience and for the skills that I acquire while doing this. And also the SIO, a replacement SIO costs like $5 to $10. I think this one was right in the middle of like $6 and $7 delivered from China. And yeah, I'm happy that it worked out. Next time I hope I can do a better job by applying solder directly to the SIO, to the pins, and then really just only use hot air to get it on, because this time I also had to solder by with my soldering iron the legs and do a little bit of drag soldering and similar to that. And I hope to just hot air it on and be done with it, get it into the right place, because that would save me a lot of time, a lot of hassle. And yeah, I hope you still enjoyed this video. I hope you learned something. Thank you very much for watching. This has been Multimeter. Thank you very much and goodbye.